Thanks, Razvan. I was telling Razvan earlier, this is regardless of what I say here today or how you guys receive it or what conversations we have of it, just being invited to come and talk at Google is definitely a high point in my career. I want to start off by thanking Google, Razvan for inviting me, Google for building all of the amazing things that run my life. I kind of did a little list of the things that would be very difficult for me to do these days without Google products and services. And it's a really long list, from my phone to calendar to maps. I mean, you guys know, but anyway, thanks a lot. So this is me at work. This is VividCortex, the company that I founded after spending a few years leading various parts of Percona and helping out in various functions in the MySQL community. I decided that I wanted to move away from command line tools and towards the software as a service tools to help people understand how their databases are performing and how the queries run and how applications use the database and things like that. So in some ways you can think of it as the evolution of Percona Toolkit, tools that I ended up building as open source and kind of merging into a toolkit in Percona. But I want to go significantly beyond that with what we do. And I'll, because it's my reality now, I'll just make a few references to it as I go, but not spend too much time on it. Basic architecture of our service is that agents run on clients' machines. Agents are written in Go. Thank you, Google. So agents run on clients' machines and send information to our APIs, which are written in Go. Thank you, Google. And our front end is written in Angular. Thank you, Google. We share a bunch of our code on GitHub under the VividCortex account. And there's a whole bunch of other stuff that we've tried to do. We try and share as much of our code as open source as possible. Obviously, there's things that would be a real competitive advantage for us to disclose, and there's some stuff that's proprietary. But we try and make an effort to get our code to be open source ready and publish it and share it with people whenever possible. One of the things that we've done is this GoDatabaseSQL.org website, which started out as just a README file. It was just a repository with nothing but a README file in it, about how to use Go's database SQL package, and in particular for connecting to MySQL databases. And then I learned about the beauty of GitHub-hosted websites, and we turned it into an actual website that's kind of a tutorial for how to use the database SQL package much more effectively. So it's kind of, in the last year or so since founding the company and getting involved with Go and writing a whole bunch of code, it's taken on a little bit of its life of its own and gone in directions that I wouldn't really have anticipated. Also, I've found the open source community around Go to be really friendly, and the intersection of Go and MySQL, there's a driver which is mentioned in this GoDatabaseSQL.org website, which is written by two guys, Arne Horman and Julian Schmidt. I've never met them. They've been incredibly helpful and friendly to me over the internet through pull requests and things like that. And the result of the work that they've done is what I think is a really high quality and very idiomatic Go database SQL driver for MySQL, which we use in production, and is fantastic. It's been great for us. That was actually, when I started to look at using Go, it looked absolutely ideal for our use cases. Single compiled binary, free of dependencies, high performance, concurrency built in, simple language, et cetera, et cetera. But the one concern that I had was, what about drivers for connecting to various things? And so this Go Database SQL driver has been great. I'm also interested not only in Go, the language, but in Go, sort of the philosophy. It's a minimalistic language, as you may know. But it has a lot of power that's actually built into the language by removing features or omitting features from the language and making it possible to use various idioms in the language that are more powerful than any features built into the language really could be. So I think that's actually been quite a revolution for me. And I'm impressed usually several times a week by something that I learn about Go, where other languages might build in a feature to enable you to do something complex. Go actually omits that feature and makes it possible to use the language in a way that supports that use case and many others. So, there's a couple of things occasionally that people mention as being missing from Go, like generics. But the more I learn about Go, the less use I have for generics. And there's other kinds of things as well. I'm also interested in other languages and programming practices that help people build higher quality software faster with fewer bugs and with better performance, including Rust, Julia, to some extent Clojure, and so forth. So MySQL. So MySQL, the state of MySQL today, in my opinion, this is largely going to reflect a lot of opinions, of course. The state of MySQL today, people often ask me, how do I feel about the MySQL community and where's it going and what's happening under Oracle and things like that. And around the time of the Sun acquisition of MySQL and then the Oracle acquisition of Sun, there was a lot of concern over, I think the term most often used was community fragmentation. And I don't use the term fragmentation myself. I don't feel that the MySQL community is fragmented. I think what's happened is that it's matured, and instead of being homogeneous, has actually developed several centers of focus. So there are people who, for example, just want to get business done, and they don't really care as long as the database is available to them and works. And the fact that Oracle is there and you can pay Oracle for a support contract is a good thing for a lot of those folks. There are people who care more about the open source side of it and really want it to be open and community developed and the community to have input into its development. There are people who care most about performance, and I've been kind of centered in that camp, to tell you the truth. So I see that these things, instead of there being a single MySQL community, what I've seen is that there are several MySQL communities growing up, which are, and again, I wouldn't call them fragmented, I would just call it a little bit more diverse. And as things have matured and settled down, as Oracle's ownership has stretched into the months and then the years, I think a lot of the fears around that have calmed. So instead of having a single dolphin representing MySQL, now we have several dolphins swimming in roughly the same direction, some of them maybe a little bit further off to the side than others. So that's kind of represents how I feel about the MySQL community these days. It's, by and large, is a good feeling for me. I still feel the MySQL community is a welcoming and friendly place, even though it's more corporate and kind of growing up and being a little bit more enterprise in some ways. Oracle, I'm pretty happy with Oracle's stewardship of MySQL as well. I guess I would say I'm very satisfied and have no significant complaints about Oracle. I know that my point of view on this is perhaps different from a lot of others, but for me, Oracle has been a fairly good steward of the code, and that's the most important thing, is actually improving the code base, because it does remain open source. There was a little bit of friction around the time of the acquisitions, and there were things like not participating in conferences and so forth. And I think we've seen Oracle kind of learn how to have productive exchanges with the MySQL community, and those they're now participating in Percona's conference, for example. Those are some pretty significant changes. There are still little things around documentation, licensing on documentation. These are kind of like long-standing things that were promised a long time ago, and you may still hear people saying, but they promised to open source the documentation, because somebody did, I think, in a moment of unbridled passion on the stage at a conference. The leader of the MySQL under Sun said, we'll open source the documentation, and perhaps it was a promise that couldn't be followed through on. But I don't really have a problem with the documentation not being open source, or open source is the wrong word, but permissively licensed. There's a few other things. The test cases are not part of the public source code anymore. It's quite clear when you look at the code that there are test cases that are excised and are internal only before the code is pushed to Launchpad. I think that's almost completely a bad thing, but it's not a deal killer for me. Security bug reports, sometimes bug reports are marked private, things like this. This is not what the open source community comes to expect, but again, these are not deal killers for me. As for me personally, we use MySQL as the backing store for all of our data at VividCortex, which is it's not anything on the scale of Google, but it's a lot of data, and MySQL is a high performance and efficient and reliable data store. So that works pretty well for us. That will change in the future. As our initial simple architecture, as we prove that our product is worth buying, and as we grow and have a lot more data, we'll build a more sophisticated architecture. And MySQL will always, I think, have a place in that. But it won't be the only data store. Probably even in the near future, we'll probably have other data stores involved. And we use Oracle's, we use stock Oracle MySQL. A couple of years ago, I would have used Percona Server because there were such serious problems in the standard MySQL distribution that it wasn't usable for a lot of things. But these days, the edge cases are very few and far between, and I think the productive interchange and competition between Oracle, MariaDB, and Percona Server have ironed out a lot of the performance edge cases. And I'd also say companies like Google, Twitter, and Facebook have played a big part in that too. So I'm going to have some words of criticism, and I just want to say that these are offered in a spirit of helpfulness, and I hope that they're taken in the kind-hearted spirit that I offer them, because there are still some areas where we can improve. But before I do that, I just want to do something that I like to do often, which is make a gratitude list. And so my Oracle gratitude list, when you really think about what Oracle has offered the open source community, it's pretty stunning. A lot of times people will say, Oracle is trying to kill MySQL, they're anti-open source, it's the world is going to end. And if you actually look at how they're interacting with the open source community, it's very clear that that's not really the case. VirtualBox, it's actually hard for me to imagine a modern development workflow without VirtualBox these days. VirtualBox is probably one of the least talked about and yet most valuable contributions to open source that Oracle has continued after acquiring Sun. There was MySQL 5.5 and 5.6, which were both great releases. 5.7 looks pretty phenomenal too. They employ hundreds of engineers, more than MySQL themselves ever employed, working directly on the database server and the things around it, like the tools. There's the MySQL Connect conference, which used to be sort of a sideshow on the weekend, and this year it's opened up into its own conference. It's a proper MySQL conference in its own right, this time returning under Oracle's umbrella as part of Oracle Open World. There's participation in Percona Live, which is the other big MySQL conference every year. There's the MySQL Workbench and lots of tools similar to that. Yum repositories were announced recently. The community team, I think, has been very productive and helpful recently. Morgan Tucker resolved a problem with some feeds on Planet MySQL for me yesterday and today. So I get lots and lots of good feelings from my interactions with the sort of the open source community face of Oracle. And finally, I just want to say that in the face of intensive, often heavily funded competition that's been sometimes really nasty and a lot of criticism and negative advertising and politics, Oracle has remained calm and just carried on. And I think that's been a huge benefit to just kind of settling the waters around MySQL in the last couple of years. So, their sense of poise and grace in receiving all of the criticism that they've gotten has been great. There's MariaDB and SkySQL is kind of another, I would segment the MySQL community these days, or ecosystem, if you will, into four really major chunks. There's Oracle, of course, and then there's MariaDB, SkySQL. I would count Percona as worth mention in their own right. And then I would lump together companies like Facebook, Google, Twitter, and say sort of corporate contributors and major open source contributors to MySQL. There are other companies like Baidu in China as well. But MariaDB and SkySQL recently have merged, as many of you know. And how many people here are involved in Google's deployment of MariaDB? Anybody? Okay, no hands go up. So not in this. Okay, one hand goes up. So there are folks in this room who are involved with that. I think I have a very optimistic feeling about the future of MariaDB and SkySQL. Recently, I've seen positive signs that there's an actual business model coming, sort of emerging out of we have an open source fork of MySQL. What do we do with it now? And a business model that's sustainable is critical for me, because without a sustainable business model, desperation might set in. And when people get desperate, they do things that may not be very productive. And I think in the past, as they were searching for that business model, there was a little bit of kind of kicking at the sandcastle of MySQL and the MySQL community. And I thought that was less productive than kind of what's happening today. MariaDB is not interesting for me because of technical differences, but just because of the fact of existence of a major fork. On the other hand, I would also like to gently suggest that we try and put the divisive politics behind us in that regard, and particularly any complaining. I just don't have any room for that in my heart. There's been, for example, a lot of complaining about how Oracle may or may not be making things hard for forks. Well, look, if you fork a product and you've got a major company who's continuing the main line, deal with it. Especially if you fork in a hostile way. Do you expect them to make it happy for you? It's the burden of forking should be on the people who fork, not on the people who maintain the original product. There's also been a lot of politics and favoritism around things like including MariaDB in distributions, which I think is wonderful. Definitely. I would love to be able to yum install MariaDB. But if I say yum install MySQL, you'd better not give me MariaDB. And I think that's something that comes from sort of a myopic point of view. And I'm not saying that that's what's happened, but there was a lot of noise around just replace MySQL, Oracle's distribution with MariaDB's distribution. And I thought that was extremely unproductive, along the same lines as what's happening in the Nagios community. Whatever you think of Nagios, the company, or the personalities behind it, or the technology, if somebody says yum install Nagios plugins, they'd better get the Nagios plugins. If you want to fork something and provide an alternative to it, fine. Let people yum install whatever the alternative is, but don't go asking, don't go giving something that people didn't ask for. And then there's Percona, and I'm a little bit biased about Percona just because of my long time there and the leadership positions that I held there. But I'll say I'm really happy that Percona is doing well and continues to grow strongly. It's another signal to me that MySQL has a strong future, a secure future no matter what else happens. And Percona is also very apolitical, and I think that's a good thing. There's not a lot of engaging in sort of the any negativity around things. And Percona releases and produces lots and lots of open source software, as well as, don't forget, the Percona Live conference, which is an enormous amount of effort and money to put on, and a huge benefit to the community. So open source databases now. I wanted to do a few things in this talk. One of them is to talk about where we are as open source database users and what's the state of the open source database landscape and where I would like to see it go in the future. And there's several particular things that I want to come out of that. Some of these are very ambitious. Some of them are actually quite small. Little wish lists. There's a few things that I would say about the open source database landscape now as opposed to when I got involved 8 or 10 years ago that are starting to change and really look different. One of them is that permissive licensing is becoming much more prevalent these days. It's not that people are not creating GPL products anymore, because they are. There's still lots of GPL software out there and new products using GPL. But personally, I'm kind of tired of having conversations about the GPL. What does it let you do? What obligations does it place on you? Can you use GPL software without paying for it? I mean, just endless. There's something about the GPL, the fact that it's not just a license, but it's also like an essay and sort of a manifesto that makes it particularly toxic for people just trying to get stuff done. And so these days, I'm much more in favor of permissively licensing things and not worrying about whether that might let somebody take my code and do something with it. I think obscurity is a much greater danger than someone doing something and me not getting paid. That said, it's very difficult to run a business with open source software. I've only seen a few examples of that succeeding, and they've all been open core, which open source purists or free software purists will call crippleware. And that's fine. I don't think it's a very good term, but I have nothing against so-called crippleware, as long as the core product is useful and productive for people, and the licensing is the licensing is truly open source. I'll point at InfiniDB's recent licensing as a really good example of kind of licensing that was a mismatch at first and then relicensed in a way that makes a lot of sense. And Oracle themselves, opening up things inside the server and building plugins, but allowing other people to provide alternative plugins, such as thread pooling plugins for handling lots and lots of connections to the server. Those are good examples of how you can create an open source product and sell things around it, whether it's proprietary plugins to help in a particular workload pinching point, or if it's the MySQL Enterprise Monitor or other tools around it to help manage it. I think those are legitimate and praiseworthy ways of doing business. Finally, I think we've seen what I would call the maturity of relational database management systems in open source, where I don't think that we can expect anything radically different in the upcoming years. And I could be proven very wrong about that, but I think that a lot of the innovation is in systems that look very different from, let's say, MySQL and Postgres. And that's not a bad thing. I think the sort of the state of the union of the relational database management systems is that they're kind of converging asymptotically towards what they should be. And I don't think that we should look for a tremendous amount of additional things to be added into relational databases because they may not be a great fit. So what we have today is kind of MySQL and PostgreSQL, the most common and most prominent members of the open source database community, although open source relational database community, although by far not the only ones. But I would call them sort of Seiko and Timex. They're not Rolexes, they're not Breitlings. These are very credible, solid, dependable, durable products that do lots and lots of good things, but they don't cost you a mint and they don't have absolutely every bells and whistles and features built into them. And I think that's actually a good thing because I think going too far into, let's say, some of the features that you might get in Oracle database or SQL Server or something like that can be overkill, and it can go beyond the point of diminishing returns for what people really want to build in large-scale systems today. There's a good question about why PostgreSQL is still lagging MySQL in popularity. And folks have asked me that a lot. I say it's replication, but there's more to it than that. MySQL shipped out early and arguably before it was ready, before it was trustworthy, before it was really a reliable open source database. And people looked at it and said, I'll improve, I'll use, I'll support. And between that and replication, the simplicity of the early MySQL, it took off. And I think that's kind of, if you look at the evolution of that product and compare it to the agile or lean business models that people talk about a lot today, looks to me like MySQL was sort of accidentally or intentionally developed in an agile way, if you want to think of it that way. Whereas there's been a little bit more perfectionism, to be honest, in PostgreSQL, and I think it has held back adoption to some extent. And there are completely different views on this depending on which camp you fall into, but that's the way that I look at it. There is a tremendous amount of sort of overlapping progress between MySQL and PostgreSQL. Each database can claim to have done some very important and powerful things first, often a decade first. And then those things will be, some of them are still not implemented today in one or the other, and some of them are in progress or have been implemented recently. To give some examples, MySQL does not have recursive queries and common table expressions, and it's now kind of it has the dubious distinction of being one of the few popular open source databases that doesn't. These days, even SQLite does. And I think it's a very powerful feature that would be nice to have in MySQL. I don't know if it's coming at any time in the future. It's something you can live without, but it's something that I feel the lack of. On the other hand, things like reliable crash recovery and really high performance in heavy and mixed workloads and all of those kinds of things, each of these databases can claim to have achieved something before the other in one or the other of those ways. And it's good. At the same time, I sometimes wish that we wouldn't have to wait 10 years for a feature from one database to be re-implemented in the other, or that when it's implemented in the other, it doesn't make mistakes that were solved years and years earlier in the first one. Because I've seen a lot of that. I've seen a lot of sort of predictable problems coming about because something was solved in one database but not another. Give an example, page checksumming's been there in InnoDB forever. And when I raised this as an issue for Postgres, if you're not checksumming your data as you read it back off disk, how do you know that it wasn't corrupted on disk? Oh, we don't have corruption. Oh, that would never happen. And immediately, a whole bunch of other heavy-duty PostgreSQL users in the room said, if we had checksums, we would find out that we do. So that's the kind of thing where it's really important, in my opinion, to take seriously what other people in some other community say is important to them. The other sort of elephant in the room is MongoDB. Although when I say elephant, maybe you think I'm talking about Hadoop. Or Postgres, for that matter. So MongoDB has what many people describe as sort of raving crowds of screaming fans that love it to death. And if you look back 10 years, that's pretty much where MySQL was at one point as well. Maybe not to the same extent. I would say MongoDB has people fallen even more in love with it than MySQL did in the early days, when there wasn't a great set of alternatives in open source to MySQL. If you looked around, it was one of the only things that you could do if you wanted an open source database. So these days, there's lots of choices, and MongoDB, in a much more crowded and noisy market, is still gathering lots and lots of rave reviews, particularly from developers. Why? Because it's approachable, it's fun, it's nice. The whole thing about impedance mismatch, or whatever you'd like to call it, between code and database, that's actually a real thing for people who don't spend their lives immersed in databases and think in sets. And so making databases more approachable and more fun is, I think in this case, in MongoDB's case, I'm not going to say MongoDB is going to win this or that battle, but I'm going to say I think they're going to be successful, regardless of whatever technical or academic shortcomings you might think the product has. I think it's just made enough people happy enough that they're going to use it. At the same time, we can see there's a lot of sort of reinvention of the wheel here in MongoDB as well. The ability to use more than one index per query. That came in MySQL in a generally available release in 2005. That was a really big deal, because you had to pick one index before that for every query. Well, MongoDB still has that limitation today. So in many ways, MongoDB actually feels really familiar to folks who kind of lived through the infancy of MySQL as well. There's a lot of things about databases that are hard, and I know I don't need to tell you this because you build databases that do really, really hard things really well. But I'd just like to catalog a few of them, because I think it's important to understand the difficulty of dealing with persistence in general. And in general, each of these points that I'll bring up over the next several slides either has to be done in the application or it has to be provided by the database. And wherever you do it, it's hard. If you do it in the database, it's a really monumental engineering problem. If you put it in the application, it may be easy at first, but eventually someday it's going to be a hard problem to deal with. So here's kind of a laundry list of things that are hard to do with databases. Here's real time. By the way, this picture is because cupcakes. It has nothing to do with real time. I'll digress for a moment. When I compose slides, I have a custom search engine that goes to Flickr and searches for Creative Commons licensed images and sorts by interestingness, which means that you usually get something that has nothing to do with whatever. And so if there's a picture of, let's say, a rainbow trout in my slide somewhere, it's because I found it on Flickr, sorting by interestingness. I like to try and make some of my slides correspond to what I'm talking about, and others just because. So building real-time applications on relational databases is really hard, because the relational model in the language doesn't itself in any sort of standard or in any sort of fundamental sense address real-time data. In other words, data is coming in real time. We want to query it perhaps incrementally in real time. We want to get results out real time as they come in. All of those things are things that you usually build either by polling the database to see what's changed, or in Postgres, for example, you can do listen and notify, but that's not available in MySQL, so how do you do that? So this is these are things that are hard to build into the database or hard to build into the app. So that's one of them. Dealing with real-time data is hard with relational databases. Very large deployments. And by very large, I mean on the order of, let's say, hundreds or more. I know there are definitions of very large that are much larger than that. But large deployments are difficult to do with relational databases, because you either have to cobble them together with sharding or something like that into what looks like a single large virtual database, or you have to have a database technology that supports that notion itself. Also, really high workloads, large numbers of connections to the database. If you've got large numbers of application servers and you're using something like, typically what I would see is Java with a fixed size connection pool and a sharded deployment. So each Java application server has a connection pool open to each set of database servers, and you just get kind of an n-squared cross product of connections opening up, most of which are not really doing anything, and suddenly the database server starts to struggle pretty badly under that. On the other hand, if those connections are doing a lot of work, then the database server is under high concurrency, and preventing degradation of service under those circumstances is hard. Admission control, prioritizing, making sure that really important things get done and less important things are done on a best effort basis. This is really important for getting utilization, which matters a lot at large scale. You want to really utilize all of that hardware and software that you're running pretty well. There's a few other things. When you build for sort of that very large scale thing, the single-threaded performance or the performance of individual queries can suffer. And so those can kind of work at cross purposes to each other. So that's another really hard problem. I mentioned mixed workloads a little bit. Lots and lots of short queries, lots and lots of long queries, long-running transactions, things that are idle in transaction for a long time. Those are hard things for a database to cope with. And yet, if you're not going to cope with them in the database and maintain availability and performance under those kinds of demands, then the application has to be smart and do things like not leave transactions open for a really long time, which, as you probably know, is it's difficult enough that in many cases you can't actually ask application developers to do that. Instead, you have to ask them to retry after you've killed their long-running transaction. So, I don't know if there's a great answer for this. I do know that some proprietary databases are better at this than some of the open source databases are, dealing with, really mixed workloads. Disaster recovery, dealing with all of the things, not just recovering from the disasters, but preparing for disasters as well. So taking backups is a hard thing. To take a good backup, you have to take a consistent snapshot at some point in time, and there are lots of techniques for doing that, but many of them are hard. Taking consistent backups across lots and lots of servers. Restoring backups, restoring large amounts of data. These are hard things to do. The database itself recovering well and gracefully after a crash. Now, obviously, there's decades of research and practice in building databases to do this, but that doesn't mean that it's not still hard. Running reliably. This is kind of a funny one. Actually, I think last year at OSCON, there was a really great slideshow from a Googler called While True Run, How Hard Can It Be, or something along those lines. Anybody remember that? It was about how to run something, and make sure that it keeps running, which turns out to be non-trivial due to problems with tools like init in Linux distributions. And I'll just pick on MySQL a little bit here. MySQL uses configuration files and init scripts by default in most distributions to run. And I never really thought that that was a bad thing until I started to see how brittle that actually makes the server. There's, on the other end of the spectrum, there's this philosophy called the 12-factor application, which is basically do everything the way that Heroku does it because Heroku, which is fine. I mean, there's a lot of sort of deep truth to be had in the 12-factor philosophy. And I was a little bit skeptical at first, but then when I started, one particular member of our team encouraged us to rewrite some applications that kind of behaved like MySQL with regards to config files and stuff. And we rewrote those to use environment variables for configuration. And we did a couple of other things. We made them not daemonize, for example. And then we suddenly found that our applications were behaving much better. And it started to make a lot of sense to me. And a lot of the complaints that I've had about MySQL, things like it loses track of its PID file and loses its mind, and the init script then does something stupid like starting a duplicate instance, or shutting down a server when it shouldn't be shut down, or it doesn't get shut down when the operating system shuts down, so it gets kill-9'd in an unclean state. All of these sorts of things. Those are problems that need to be solved either in the database, or you need to solve them yourself the hard way, as we've done at VividCortex to get things to run reliably. And I know, given that while true run talk from the Googler at OSCON, similar things have been done in Google. Extensibility is hard. If you don't make your database extensible, then you have to extend it with the application. I'll come back to that topic a little bit later. Schema changes are a really big deal, especially at large scale. And if you have online, non-blocking, transactional DDL in the database, that's a beautiful thing. It's a very hard thing to build into the database. So if you don't have it there, you end up having to build it into your deployment processes, and lots and lots of tools have sprung up around MySQL for doing this. Facebook's online schema change, Percona's PT online schema change tool. There's another one as well in the common schema from Shlomi. So this schema change problem is yet another thing that's hard, either in the database or in the application. Take your pick. Query plans and query planning. The bad thing about having a database that can run queries as opposed to simple gets and sets is that the queries have to be planned, and the plans can have worst cases. And people can easily kind of shoot themselves in the foot with the worst cases without knowing that they're about to do it. The good thing, of course, is that you can declare what you'd like from the database, and you don't have to write query plans into your application code. If you are using a database that just does simple gets and sets, you end up with query plans in your application code. So they're hard in either place. Doing background operations like maintaining the table space, defragmenting data, purging unused data, call it vacuum in Postgres. Those are hard things to do without blocking the foreground operations of the database. This is not something that can really be moved into the application in any credible way, so this is just hard to do in the database, period. ACID transactions. I love ACID transactions. They are such a simplifying and such a force multiplier in many cases. But they result in lots of types of things that are hard, and hard not only in the database, but sometimes hard in the application to deal with. The alternative, of course, is roll your own transactions in your application, which is not a solution that I'm interested in particularly. I've done it, but I've never enjoyed it. Replication, we can probably just leave it at that. Replication is hard. And to be done credibly almost always has to be done in the application. Sharding or distributing data really needs to be done in the database in the future. I think this is going to be in my list of things that I want to be done in, let's call it, next generation databases. But often it's done in the application today. Sometimes in sharding frameworks or middleware, things like Vitesse or JetPants, or MySQL now has this thing called Fabric, and there's Tungsten, Continuant Tungsten, and there's lots and lots of sharding proxies and sharding middleware and so forth and so on that are trying to abstract a set of single node database servers and make you think that there's one big database. And by and large, it doesn't work very well. The problems, there's a couple of problems. One is that sometimes the products are built by people who aren't practitioners, in which case they may not serve real use cases, or may not serve them completely. And if you don't serve something completely, let's say you have a 95% solution, what I've often observed is that in practice, 95% of people then can't use it. So you have a 95% solution that 5% of people can use. So it's like this catch-22 if you're trying to build something that's generally useful. Another problem with sharding frameworks like these is that they're often built by practitioners. So you're sort of damned if you do and damned if you don't. But if you are, if you build a sharding framework for your application and then open source it, it's often very difficult for people to assess and think about what this sharding framework or middleware or whatever it is, how it's going to behave. Like the database underlying it is complex enough. And now you're giving me a layer over top of it that I have to evaluate and think about whether it's going to meet my needs, and in what cases is it going to fail, and what are the, where are the lift points on it, and what sorts of nasty things am I going to have to deal with. And so that's often scarier than just building sharding into my app. So that's what ends up usually happening. I haven't seen any sharding frameworks or middleware really adopted at large scale. And I haven't seen any proxies, sharding proxies, actually really solve the problem either, in my opinion. So what often happens is you just sort of build a best effort good enough into your application, and now you've got a sharded application to deal with. So this is hard sort of no matter which way you look at it. But I'll return to this later. I think it's largely because we're dealing with a single node database that we're trying to use as a multiple node distributed database. And that's probably not really the best fit. It's probably not doomed to failure, but it's not necessarily going to be a smooth and wonderful experience. Performance management is a particular challenge. This is really near and dear to my heart for reasons that I'll come back to again and again. But troubleshooting databases, especially in a large deployment, under heavy load and lots of different things going on at the same time, troubleshooting what goes on in the database and managing performance in general is a real challenge. And to some extent, this can be supported within the database. To some extent, you can architect your application smartly, but you also probably just need external tools as well. So the application performance management market has done really well here. Tools like New Relic, App Dynamics, and so forth. Of course, there's also things that are, let's say, distributed tracing like Zipkin, or AppNeta is actually built on the same thing, Xtrace. So there's lots and lots of tools that you need, both within and without the application and the database server. And it feels like something that can often be punted, but eventually it comes back to the point of, okay, we have a lot of database servers now and a lot of applications accessing them, and we really need to understand what's going on, and that's hard because we haven't built for it yet. So, for example, at VividCortex, we're in the process of maturing a framework. It's actually open source already. It's called PM, stands for Process List Manager, for building the notion of something sort of similar to MySQL's show process list into API servers, or any type of server that accepts a request and does some work and returns the response. And so what we're trying to do is build ourselves a distributed ability to look at every process that is currently running in all of our API servers across all of our machines, which is, even at our small scale right now, is already hard to do without tools like that. So, so there's lots of work that needs to be done to make that happen. A lot of that is enabled or prevented by instrumentation or lack of instrumentation inside the systems that you're trying to introspect. However, the instrumentation inside the systems can come at a cost. Typical ways to do it in MySQL are through things like status counters and the performance schema. Performance schema is getting a lot better, but it's really complicated. Everything has really long names, and I think you'd have to basically live in it day in and day out to make much sense of it, and to kind of know where to look for the data that you're looking for. Also, it's inherently limited. You only get the data out of it that somebody thought was useful to build into the server ahead of time. And if you need some additional information on a running database server, you're going to have to get it one way or the other. And that's often something that's not instrumented. Percona prefers to use the slow query log. I have slowly sort of fallen out of love with the slow query log for instrumenting what goes on inside of the server, in part because of the same things. It's slow moving. If you don't get a particular statistic in the slow query log, you're kind of out of luck unless you want to rebuild your server. But also because logging is pretty resource intensive and it's dangerous. It can run your disk out of room and crash your whole database server, which is, in my experience, the #1 reason that database servers crash. And finally, doing something with all of those logs is really expensive. So there are ways to work around that, like sampling and partial logging and things like that. But those are not answers that I'm happy with. So what we've opted with at VividCortex is to capture the network traffic, decode the protocol, and then anything that we can't observe from that, which seems, that actually seems very limited, right? But anything that we can't observe with that, we're now building a system to compute based on particular regression techniques and so forth. So we actually can get things that are impossible to measure anyway, and we can do it after the fact with essentially no performance impact, and we can ask ad hoc queries that we didn't have to instrument ahead of time. So there's a lot of benefits to that. We're still early, but we'll see how it goes. So far, it's looking very promising. configuring and reconfiguring the database is something hard because a nicely operable system has to be reconfigurable on the fly, which introduces all sorts of interesting things into the code. But if it's not, then it has to be shut down and restarted, which in many cases is that's a showstopper. Can't do that. So there's sort of a spectrum from things that are hard-coded to things that are configurable when the process starts, to things that can be reconfigured during runtime. And then the holy grail, maybe not the eventual holy grail, but the slight holy grail beyond that for me at the other end of the spectrum would be things that are adaptive. You could maybe configure them if you wanted to, but they figure out what's going on and adapt themselves. And I think SQL Server has done a really good job with this. It's, with air quotes, it's self-tuning. And talking to people who are SQL Server experts, I used to work with SQL Server, not an expert in it by any means, but talking to experts, they tell me that it does a really good job. Benchmarking. So benchmarking is hard. There's a theme going on here somewhere, I know. Benchmarking is hard in part because benchmark tools are often really miserable to work with. They do silly things that are unrealistic, like drive the database or other system that you're measuring past the point of good performance. They'll drive it as fast as possible, way over capacity. And if you're trying to ask a question like, what's the maximum capacity of my system with good performance, you won't get it if you're just bringing it to its knees with more load than it can handle. So that's kind of a go really fast as you can is sort of a fundamental assumption of a lot of benchmarking tools, which makes them really unproductive for a lot of things. The benchmarks themselves, and the tools also, by the way, can be really hard to use. Like Sysbench over the years, I think has almost devolved. The last couple of times that I've used it, I've had to use older versions because newer versions I either can't figure out how to use or they have bugs that prevent things that I was used to relying on from even working. So I don't know, maybe LinkBench or other benchmarking tools are an improvement here. Maybe there's a better breed or maybe Sysbench is going to be improved again in the future. But for right now, benchmarking just looks really hard to me. Finally, after you've done this benchmark, you realize, oops, I goofed something up. And a good benchmark can take hours or days to run. So whole thing's invalid, start all over again. Got to get resources for this, got to get time for this. It's just doing good benchmarks and doing them well is so much work. This is partly why I'm really thankful to Vadim at Percona because he does a good job with his benchmarks. Every time somebody asks me what I think of another set of benchmarks, it's not that there are not other people doing good benchmarks, but Vadim's benchmarks usually impress me pretty well. And then the last thing I'll say about benchmarks is that it's almost impossible to extrapolate what happened in that benchmark and how is that going to have anything to do with my application. Even when you try with things like LinkBench to build benchmarks that more closely resemble your application, I think the best you can do with benchmarks often is compare that benchmark against itself with different settings or something like that. So useful for improving the server's performance, but not necessarily useful for extrapolating to real-world applications. So conclusion is databases are hard. No surprises there, right? So what can we do? There's a set of tools that I think are useful for dealing with hard database problems. And I'll just go through a couple of those. These are some of my favorite techniques, and I won't go into great detail with a lot of them. Queuing theory, I think everybody should have some grasp at least of what queuing theory is about. The math is really hard. It requires understanding probability, which I don't. And so I'll fully admit that I am not the person to explain to you in depth why queuing theory works, like particularly the Erlang queuing theory equations. I'm not the person to explain to you how they work. I know that they work. I know they're a little bit difficult to use, but that when you get the principles behind them, it's sort of a reorienting set of mental principles to guide building applications. So that queuing theory, those principles behind them can be gotten without studying queuing theory itself. In particular, there's a book by Ellie Goldratt called The Goal, which I love. It's a novel and explains in intuitive things like Boy Scouts hiking along a trail how queuing theory works and why systems go fast or slow and why things get inconsistent and pile up and get bottlenecked. So that's one of my favorite books. This Little's Law, by the way, has nothing to do with coffee. It's just because coffee. So who wants a cup of coffee? Little's Law is one of the unifying principles behind measurements of performance. So Little's Law says that concurrency is equal to, long-term average concurrency in a stable system is equal to long-term average throughput multiplied by the long-term average response time. And those three metrics are all about units of work, which is one of my sort of founding philosophy principles for VividCortex, is that you should care about the work that systems do. In the database, the unit of work is a query. In the file system, the unit of work is typically an I/O read or an I/O write. So those bits of work are really what we should be caring about in our systems. And so Little's Law is kind of core to that. And these three metrics, throughput, concurrency, and response time, are really important in understanding that. Another thing is Amdahl's Law. This is a mathematical way of saying if your system is 5% serialized, where serialization, the portion of your system that's serialized would be the sigma. If your system is 5% serialized, no matter how much you parallelize it, you can only cut out 95% of the runtime. So the best you can do is make it 95% faster, which is 20x speed up. So Amdahl's Law gives us a very clear and intuitive explanation of sort of the asymptotic best case behavior that we can get out of a system when we try and parallelize it and it has some serialization in it. And going beyond that is Neil Gunther's universal scalability law, because chocolate cake, which adds an additional component into the denominator there. That additional term has a kappa coefficient in front of it, and kappa here represents, when you parallelize something, how much crosstalk has to happen between the units of workers that are happening concurrently in order to coordinate and make sure that they do their work correctly. And the universal scalability law is, in my opinion, a very elegant and powerful model of how systems scale and why they don't scale as well as they should and why their performance drops off under higher concurrency in particular. So you can, it's a closed form equation, and it's easy to regress to some sample data sets. And you can gather these samples easily, which is something that you can't say about formal queuing theory. The data that you need to do modeling with formal queuing theory is very hard to get. So you can get these samples of throughput and concurrency. Notice that the throughput concurrency are the only two things that you need in this universal scalability law. So here we're dealing with a subset of Little's Law. We're dealing with basically these three metrics, these fundamental metrics of performance around units of work in your system. So you can measure throughput and concurrency in your system in the wild very easily and regress it against the universal scalability law and do useful things like how close am I to the maximum capacity? How much more capacity can I expect out of my system beyond what I'm able to measure? If my system looks like it's suffering under increased concurrency, what's causing that? And what can I do to fix that? So it's a framework for describing why things scale or fail to scale, and for understanding and putting things into a logical model of how to do better. So these fundamental performance metrics that I've been talking about, throughput, response time, concurrency, those are really basic. Utilization can be derived from those. The things that we can measure on systems really easily, even from things like TCP traffic, which is part of what we do at VividCortex, is the arrivals and completions of these units of work. So some query arrives at the database server. It's now inside the database server. We can increment concurrency. When it leaves and goes back, we can decrement concurrency, and we can measure the elapsed time, and we say that was the response time. And we count the completion, and that's our throughput. So completions per unit of time. So these just measuring arrivals and completions is a really powerful technique for being able to pull all of these things out and do all of this rich modeling with things like the universal scalability law. Models are dangerous because you can sort of get model tunnel vision and start cramming your system's behavior into some model that may or may not fit. This is a recent tweet from Hillary Mason, who's at a venture firm now, but she was formerly the chief scientist at Bitly. And There's lots and lots of sayings that are similar to this. All models are wrong. Some models are useless. I like this picture of Da Vinci's helicopter. Theoretical helicopter theoretically might fly. Everything that's simple is false. Everything that's complex is unusable. There's some spectrum between models that are simple enough to be applied and therefore useful, and models that are correct but too difficult to apply, such as queuing theory. The map is not the territory. That's actually a philosopher. And then there's another modern philosopher, Neil Gunther, who says all measurements are wrong. Those are essentially statements of the same thing. In a talk very much like this one, Neil Gunther said, all measurements are wrong. Who knows what that means? And he pointed at me and he said, Baron, I know you know what that means. And I didn't know what it meant. But a few minutes later, the light bulb went on. The measurement of a quantity is not the same as the quantity itself. That was such a revelation for me. It was such a simple thing. But I was flattered that Mr. Gunther had such faith in me. So here's some interesting things that I continue to study and in some cases apply. Regression, there's lots of different types of regression. I'll probably spend the rest of my life learning about them. I've sort of quasi-invented a variation on regression that we actually use in production and find very helpful. Forecasting. Regression can be used for forecasting. Lots of techniques can be used for forecasting, including things like analyzing time series metrics for periodicity, seasonality, and predicting where they're going to go in the future, those kinds of things. In fact, most work around time series metrics, as far as I've been able to discover, has really been in one way or another trying to forecast what that metric is going to do 1 second from now, if not a long time from now. It turns out that even predicting what the next measurement is going to be is pretty hard. Anomaly detection is another way of saying the same thing. If I forecast this metric to be a certain thing and it's outside of my expectations, then I can call it an anomaly. I use exponential moving averages to death, and I love them to death. And I wish that I were able to invent something that had some of the properties of exponential moving averages and gave me some other desirable properties, like exponential moving regression, which is something I'm working on. Control charts, if you can forecast, you can draw control lines, and if your measurements fall outside of what you expected, then that's essentially applying a control chart to measurements. Some people don't like Holt-Winters or double and exponential smoothing or other seasonality methods, and they like to use fast Fourier transforms, and that's something that I'm interested in but I haven't done myself. And the final thing is supervised learning, which is a fancy way of saying that I take some data, I look at it, slice it, dice it, pull something out of it, write an algorithm to do that again in the future, deploy it into production, and then repeat. So that's my supervised learning method. And those are all kind of things that I'm working towards or working on, sort of cooking up a performance management solution. So I want to talk a little bit about performance management. And by the way, feel free to interrupt me and ask questions at any time. But I wanted to talk a little bit about performance management because people often say, oh yeah, you're building a MySQL monitoring company. And I don't want to build a MySQL monitoring company because I think monitoring is kind of the wrong tool. Monitoring says thresholds and alert checks and health and is it up or down, and that's not necessarily, I think, what people really need most of the time. Most of the time when people install a monitoring tool, there's somewhere kittens are dying. They really should have installed a performance management tool instead, because performance management tools care about the work getting done in your systems. And I think if you look at the user interface of application performance management tools, you'll see that implicitly or explicitly they are very focused around revealing to people visually or with numbers the work that's getting done and how good the performance is and what needs to be done, where you should direct your attention. And monitoring doesn't do that. Monitoring takes metrics or monitoring checks and sees if something is alive, but it doesn't know anything about the metrics. It doesn't know anything about the meaning of them. It doesn't have any predefined notion. It's just these monitoring tools like Nagios or Graphite or so forth are by and large just drawing charts and maybe allowing you to do some nice things with the charts and telling you whether something is alive or dead, but they're not really measuring the work getting done. So, and the reason I care a lot about this is because almost literally, figuratively, the sky is falling as we deal with lots and lots more data. And, you know, I'm caught in this. A lot of my good friends are caught in this. The data that we're dealing with is just growing and growing and growing, and we can't really scale proprietary expensive systems to those levels. So we turn to open source software because it's cheap, maybe even free, like a puppy dog. And as a result, we install things on our servers that have no really strong revenue stream around them. And since there's no revenue stream, it means that nobody has invested millions of dollars making them really easy to manage or making them easy to measure and understand or building really good tools around them. And so you've got really large-scale distributed systems without good tools to manage them. And this throws the burden back onto the people that we were really overburdening already in the first place, which is the operations staff most of the time. Database administrators, developers to some extent, but largely it's operations staff who in most organizations are responsible for firefighting when things go south in production. And so it's, in some ways, it's a vicious cycle. And the only thing that I can see that can make it better is tools. So, you know, that's what we're trying to do at VividCortex, is build better tools for performance management. Tools drive methods. If you give somebody a hammer, they'll bang on things. If you give somebody a screwdriver, they will twist and pry and poke. If you give them performance management tools, they'll manage performance. If you give them tools that are based around a performance management methodology and a mindset, they will follow it whether they realize it or not, especially if the user interface follows it for them and just presents them the results. So I really want to build tools that express a process, implicitly preferably. I don't want to beat people over the head and educate them. I just want them to be able to do things without sort of going down wrong troubleshooting paths and looking at metrics that may have nothing to do with the problem and sort of ending up with the tail wagging the dog and the cart before the horse. I want to build better tools so that people automatically do things better. And there's nothing that I've ever observed that's more powerful for driving a process. For example, the tools that I built at Percona were largely to try and drive a better process for the consulting team. And it really worked. So again, for me, the central thing of concern is the work getting done? And is the work getting done consistently and with good performance and good behavior? The other question that I want my tools to answer is the so what question. If you show somebody some data or you tell them that a metric is so-and-so, you have to be able to answer the so what question. You know, CPU usage is 100%, so what? The disk is getting full, so what? If you can't tell people why this matters and what the consequences of it are, then you haven't followed it through all the way. And I want the tools to follow through all the way and help people to answer the so what questions. So to give you an example right now, PT Query Digest from Percona Toolkit will show you which queries consume the most time on your systems. So what? You have to do all the rest of that work yourself after that to do anything with that information you've learned. I created an acronym for this, the things that I really care about in systems: capacity, availability, performance, and scalability. And those are the things that I want my tools to care about the most. Performance, I'll just mention briefly, there's two aspects of performance that I'm most interested in. Carey Millsap defines performance as response time. That is the time it takes to complete a task or a unit of work. I think there's another dimension of performance that's really helpful, which is resource performance. So Carey Millsap focused on task performance. Resource performance is usually expressed in throughput. How many units of work can my system perform with good behavior? You know, meeting a service level agreement, for example, a 95th percentile response time or something like that. Availability is really important to me as well. I want my systems to be highly available, which not only means that they're up and responsive, but they're responsive with good characteristics. I want my response times and my throughput to be really consistent and predictable. One of the sort of gremlins that happens a lot in MySQL systems is short little stalls. This is not limited to MySQL, by the way. You can look at almost any system, like it's even in the React documentation. I can't quote the numbers off the top of my head, but it's something that's sort of appalling about how long the system will pause and how often. And those kinds of short little stalls are momentary downtime and unavailability of the system, and I want to kill them. I want to detect them at a very fine granularity. I've invented an algorithm called adaptive fault detection, and you can look at some of my past talks online for more details on that. But the idea is to be able to detect these short stalls and to know whether they're inside or outside of the system. So if we see MySQL not doing any work, is that because it got stuck? Is it because the disks were stuck? Or is it because somebody restarted the application servers and it suddenly didn't have any queries to perform? So those are important questions to answer. And I really want that. So our algorithm doesn't need any pre-configuration, and that sort of adaptive algorithm, again, is kind of the holy grail for me. There's a set of metrics that systems expose, and a lot of them are easy. Developers include them in the system, like show status counters or whatever, because they were handy. It was something that was easy to count and then just expose. But with a little bit of forethought about the metrics that I told you mattered earlier, response time, concurrency, throughput, those kinds of things, most systems you can get throughput from, but otherwise to get response time and concurrency, most of the time you have to do something yourself because it's a black box and it doesn't provide you that. So there's this set of metrics that's usually baked into a system in some kind of a status command, most of which are not useful. A handful of them are useful, and then there's a whole bunch of things that are highly desirable but not included. So for the most productivity, my recommendation is to focus on the overlap of those areas between the easy metrics that you can get and the metrics that you want, and ignore a lot of the metrics that you'll get out of a system status command because they're not really useful information. So, as I mentioned, I'm heavily influenced by Kerry Millsap, and this is his book. I recommend it for anybody who's interested in these topics. And there was a link on that slide also to an ACMQ article, which goes beyond what he talked about in his book, which is really great reading. Databases are heavily concerned with storage and indexing, and that's changing now and in the future. There's going to be a lot of changes to storage and indexing. And I think there's a lot of exciting things coming out here. In the beginning, there was the B tree. This is sort of like everything, the mature database systems that we have today are largely built on B trees. Up and coming database systems are built on things like log structured merge trees, like Google's LevelDB or Tokutek, their fractal trees, fractal tree indexes. There's a variety of other things. Skip lists are popular in some newer products as well. So these more advanced data structures and algorithms, I think, hold a lot of promise for improving performance. But we're still kind of in the land of the tree. And we're dealing a lot with the existing algorithms, and understanding them and their characteristics is important, I think, to making better products and to dealing with the products that you have and understanding how to get better performance out of them in particular. I'll touch briefly on the cloud. I'm not, I have a probably well-deserved reputation for being a cloud skeptic because I've spoken against clouds, in particular the Amazon cloud, a handful of years ago. The machines that were available in it were very low performance and comparatively very expensive compared to your own machines running in a data center. But I'll say VividCortex is running entirely in the cloud. As of a month ago, we shut off one of the machines in my basement, which was just a staging system. So we're now completely in the cloud, in the Amazon cloud as it happens. And it's not a bad thing. We're doing okay. I could get better performance out of some Fusion IO drives or something like that. But we've managed to figure out how to architect around the limitations. And for a startup, it's lowered our cost of entry and cost of getting started with the company overall by at least a factor of 10, and allowed us to move in months what would have taken probably the better part of a year before. So it's been a great thing for us, and call me still a cloud skeptic, but I think things are improving. And we're not really approaching the utopian ideal of utility computing yet, but we're getting in that direction. Right, things are definitely going in that direction. And I don't want to just mention the Amazon cloud because there's lots of other things. There's like Google Cloud SQL, and in addition, there's other people who are bringing out platforms for database as a service, and there are even cloud native databases that are coming out these days. that are designed to run entirely in the cloud. So, there's a lot of innovation going on, but we're still, where we are right now is we're kind of grafting old-style infrastructure into stuff that's hosted in a virtual environment, and I don't think that's the full potential of where we can get to eventually. And then NoSQL. So this is a much more interesting and fun topic, I think, because I've been simultaneously, for years, I've been a critic and an advocate of NoSQL systems. I'm not an advocate of the name. I think it's an awful name, but even I can't think of anything better, as critical as I am of it. But what's really interesting is that there are a lot of innovations. We've really moved the state of things forward in the last few years. I know the folks at Google with the Spanner and F1 projects know a lot more about this than I do. But even things like eventual consistency, the Dynamo model, the distributed consensus algorithms that have come about in recent years, like obviously Paxos is very widely used but very difficult. There's now Raft, and there's the algorithm whose name I forget that's in Zookeeper. Is it Zab, I think? Something like that. And so, that's this whole sort of distributed systems research. This is where I see things as being interesting. The no to SQL or the not only SQL, that the interface or the data model are not the particularly interesting things to me. The interesting things are the distributed systems and how we can build systems that run, databases that run across more than one server natively. Like not just sort of bolting together a bunch of single node databases and making them think that they're a big single database, but building things that are, it's the core identity of the software itself is that it runs in a distributed fashion. And this is not necessarily new either. There's Tandem and the, what was the operating system on Tandem? Yeah, so nonstop SQL, but there was a name for the operating system as well. Sorry, say again? TCL. That's not the word I'm looking for. Oh well, word retrieval problem anyway. So this stuff was done decades ago, right? Distributed, really reliable, very high performance SQL databases running across clusters of machines. So it's not necessarily 100% new, but there is a lot of innovation. At the same time, I think the innovations have to be approached cautiously and not sort of with a Kool-Aid drinking approach. This was one of the funniest tweets that I think I've ever seen from Stuart Smith. Stuart is, if I can characterize him, speak on his behalf, I think he's pretty against eventual consistency. I think it has its place, but I think you do need to be aware of the barbs that can come with it. At the same time, there's a ton of reinvention. If you look at MongoDB, I do not count MongoDB as a distributed system. It's the same thing as MySQL with master-slave replication, and each node is a node unto itself, and then there's this sharding proxy in front of it, which tries to make it look and behave like a distributed system, which may be good enough. I'm not saying that it won't work. I'm not saying don't do it. I'm just saying this is not what I call a sort of native distributed system. In a distributed system, the data is distributed in an intelligent fashion. Queries are distributed, right? So queries don't just run in one node. This, by the way, means that you need to have the notion of a query. Cassandra, for example, doesn't have the notion of a query. It's basically you can do multi-get. But that's not a query. What I call a query is something that actually expresses declaratively what you would like to be done. And then that query, that expression, is compiled into a program and executed on the database server. In Cassandra, you can't execute expressions. There's no notion of an expression in Cassandra. You can put lots of data into it, and you can get lots of data out, and then you can operate on that data, but you can't send an operator to the data itself. So distributed databases need to distribute the data, the queries, and the work represented by those queries, and the decisions. So we can't have a single node system that lives in this mindset of I make decisions on my own and bolt that into, I don't think that we can. I don't think that it will really work. I don't think that we can bolt those things together into a distributed database. So, so for me, actually, Cassandra is a good example of a system that distributes aside from the lack of queries, I think it distributes things in a very sensible way. So there are great databases, MySQL, PostgreSQL, et cetera, but I don't think that they will ever be great distributed databases. Here's my wish list for what we could do to improve the great single node RDBMSs that we have right now towards some of the things that have either been innovated in other relational databases or towards some of the stuff that has come about in the NoSQL systems. And then I think we should kind of stop there, because if we're trying to take these products and go that much further with them, it's probably better that we just think about other systems that are more suited to that instead, because relational is not the be-all and end-all. The other thing I want to do is I want to try and avoid too much diversity in my tech stack. So there are lots of databases that are particularly well suited to something, let's say full text search. But if that's not the core of my application, maybe it's better off for me to use a relational database that has a text search function, even if it's not as amazing as Elasticsearch or GIS, even if it's not as amazing as a database that's designed for geospatial queries. It might be better for me to use a fewer number of products that can sort of do some things really well and gesture at other things around the edges a little bit than to run a whole bunch of different products. And so I think that's where relational databases, I think, should go. And search, that's a great thing to have. Full text search is a great thing to have in a relational database. JSON, we've had XML in databases for 10, 15 years now in relational databases. Put JSON in there too. It's really convenient. It's really nice. But that doesn't necessarily mean that it is a JSON database. So those are some of the NoSQL things that I'd like to do in current generation relational databases. The things that I want from my next generation databases, I'm going to flip through these mostly pretty quickly. I want reliability. I want really reliable distributed systems because rainbow trout. I want high scalability, high performance. I want them, as I said, to be distributed by nature, sort of like native distributed systems, not bolted on afterwards. I want them to be extensible. So I was talking to Foundation DB a month or so ago, and I said, I really want to be able to run queries and operators in the database itself. And that's something that, for example, Aerospike allows you to do in Lua. And that's really important, to be able to extend the product for uses beyond what it was originally conceived for. I want it to be developer friendly, like MongoDB or Redis, which is a huge force multiplier, even though it's not a distributed database sort of from its inception. I want databases to be that friendly to use. SQL is here to stay, but that's not necessarily to say that it's a beautiful thing. I want it to be manageable, and by that I mean that I want tools to manage, but I also want to eliminate the need for tools as much as possible. I want the database server to be very efficient so that I can get a lot. I don't have to throw 1,000 nodes at something. I want to be able to do it on my laptop. And there are highly efficient databases that show us that a lot of that is possible. There's also databases out there that claim to be perfect. These are some claims taken from recent marketing of particular databases. I think that unicorns and pixie dust was in one of the up-and-coming databases' recent press releases somewhere in there. I'm really skeptical. I mean, the problem is that marketing makes it hard to understand what you can actually get from these databases. And I want those failure points and the promises to be really credibly done and explicitly made so that developers don't believe they can get something, or ops staff don't believe they can get something from their database that they can't actually get. The only thing worse than believing that your database is durable and resilient and handles clustering and failover and all of these kinds of things well is believing it when it isn't true. If you tell me that it won't handle that kind of scenario, then I won't subject myself to that possibility. So here's a list of some of the databases that I still am very impressed with, both the way that they communicate the capabilities as well as the capabilities themselves. And there's a few here that I'm still looking into, like Druid. We're doing a proof of concept of Kafka right now. In some ways, I'm not even a fast follower. I'm very conservative in these matters. But these are some technologies that still remain interesting to me and that I think will be successful and important in the future. The other big category that I wanted to talk about is time series databases, because time is almost always an element in every metric that we take. So the notion of handling and working with changes and series of metrics over time is really important, and it's not built into many databases today. There's a few. There's Vertica that has kind of a little bit of a variant on their SQL dialect that can deal with a little bit of time series. There's a couple of promising up-and-coming ones like Druid and InfluxDB, because beautiful picture of guitar. But I really think that the future is going to be increasingly time series, and so I think databases like InfluxDB, Druid, New Relic's Rubicon looks like it has time baked in as a sort of primary concept. And we don't really have anything that's good for that today. What we do is we typically build on top of low-level components that don't have a query language, things like Cassandra. Cassandra is heavily used for time series data. And the main regret that I've heard from talking to people who have built and deployed large-scale time series databases is that every time somebody wants to do something, like management wants to run a report, you've got to involve a developer. And not a developer who knows how to write a query, but a developer who knows how to write an application that goes and does a whole bunch of operations against this low-level thing that we call a time series database. And I don't think that those are proper time series databases. They certainly don't satisfy me anyway. So I wanted to close with maybe book recommendations is not the right term here, but books that I've really enjoyed recently, most of which have nothing to do with technology at all, but I just thought I'd share with you some of the things that I've enjoyed. 7 Habits of Highly Effective People. If I could boil that book down to a phrase, it would be, you are free to choose your actions, but not free to choose the consequences of the actions. A book that my brother shared with me not too long ago is called The Road Less Traveled. And the phrase that I would pull out of this is, love is not a feeling. And oftentimes when I say that, people have a really negative reaction to me, and sometimes we've gotten into heated discussions. I mostly try and stay out of that. But read this book about 3 times and tell me if it doesn't change your entire worldview about love and being loving to people. The 4 agreements, in my screen sharing view, I don't have my slide notes up here, so I can't quote these off the top of my head. But there's, if I can try and get them, I'll just try a couple of them. Don't take things personally, because it's not about you personally. When somebody behaves in a particular way, it's really about that person and what was going on inside of them, and all of these other sorts of things that you have no idea about. This is a lesson that I try and teach myself, usually try and reteach myself every day. And hopefully I think I'm making slow progress on it. I don't know how to pronounce this man's name, but this book was just really inspiring to me. I guess the phrase that I would pull out of this book and share with you is that life exists only in the present moment. And I think the quote might be something like, salvation exists only in the present moment. And I fully agree with that from any philosophical standpoint that I take. The last lecture is about a man who was dying, and he wrote a book about life. So highly encourage reading that. Here's something from another man who died recently, Seamus Heaney, famous poet, Nobel Prize-winning poet. And after he died, I realized, I've never read any of his poetry, so I got this book. And it has just been an amazing read. This man was able to say things that were just, I would have thought were unexpressible. He grew up in rural Ireland, and I grew up on a farm. And his poems about picking blackberries or walking through the mud or mundane things like that are so powerful to me. But at the same time, he grew up in Northern Ireland and all of that conflict. And he's able to say gracefully and lovingly the truth about what was happening. I feel like sometimes when I'm reading one of his poems, I feel like I'm growing up in Northern Ireland with him. It's an amazing, amazing book. Man's Search for Meaning. I read this one probably 6 months or so ago. This is from a man who survived the Nazi concentration camps. And as far as I can tell, lived a happy life after that, which is more than I think I would You know, if you were to send me to a concentration camp right now and ask me, are you going to be happy coming out of it? I'm not sure that I could be. I'm not sure that I could deal with that. But a tremendously inspiring book. So here's my contact information. And always love to hear from people. I'll post my slides online and a little bit of maybe narrative in a blog post about it as well. That'll be on my blog, xaprb.com. And I hope this has been fun, open to any questions. Otherwise, if it's lunchtime, let's go eat.